Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of symmetry, which coincides with odd and even functions. The same tests for symmetry also determine whether your function's odd or even. Alright, so what is symmetry? Well, basically, whenever a function is symmetric, you're able to fold it over onto itself and get a perfect match. So that means that somewhere in the function there's an imaginary line that we will refer to as the line of symmetry if it's two-dimensional. If it's three-dimensional, there's usually a plane of symmetry. But here we're not going to deal with that in algebra or pre-cal. Then if it has this line of symmetry, it will be symmetric. So there are some tests, basic tests that we can do to determine if something is symmetric about the x, y, or origin. If we're discussing these tests, it'd be worthwhile to note that the same test for y-axis determines whether a function's even, and the same test for the origin determines whether a function is odd. Again, y even, origin odd, O. Y even. However you want to do that, memorize it, okay? So let's look at the first case scenario. The first case scenario is symmetric about the x-axis. So x-axis symmetry, we plug in a negative f of x and simplify it to see if we get a f of x. Another way to write that is x comma negative y to simplify to x comma y. That means we're replacing negative y, and when we simplify it, hopefully we're going to get the original function. All right? The easiest example of this, even though it's not a function, is y squared equals x. The sideways parabola, when we plug in a negative y right there, you should see that the negative sign squares to become positive and then gives you the original function. So therefore, we can determine it's symmetric about the x-axis. All right? So again, negative y in place of y. Simplify if you get the same thing, symmetric about the x. Now let's look at y-axis symmetry. The easiest example is the parabola x squared. You can see this line of symmetry going right down the middle, and if my picture was a little bit more accurate, you would see that it would fold exactly onto itself. Same thing with here, the line of symmetry is the x-axis, or y equals 0. So here, what you do is you plug in a negative x instead of the negative y we did up here. So the negative x plugged in, when simplified, give us the original function. Try that out. If you plug in a negative x here for x squared, you will see it will simplify and disappear. Become positive when you square it. And then if that is true, then it's symmetric about the y-axis. But there's one additional thing you can state. You can now say that this function is even. This is the same work you would show if you were asked to determine whether it's even or not, or odd. All right? Note, there was nothing for the x-axis symmetry, only for y-axis and for the origin. Okay, so then for the origin, the final test is you plug in a negative f of x and a negative x. In other words, a negative x and a negative y, and simplify. And if so, if it simplifies to the original, then it is symmetric about the origin. Okay? And it's also an odd function. Same test. All right? A quick clue is that if it's not symmetric about the x-axis, not symmetric about the y-axis, but the answers to both of these equal each other, that means that it will be symmetric for the origin. You still have to show the work, but that's a good way to be aware of what's going on. I plugged in a negative y, didn't work, so not symmetric about the x. Negative x didn't work, not symmetric about the y, but these two answers do equal each other, so it's going to be symmetric about the origin and odd. The example I used for that one is x cubed. If I had drawn that accurately, that would also be symmetric about the origin. All right? So I hope I've clarified things for you. All you have to do is practice, practice, practice these. You will see that they are not too bad. Make sure you check out the example videos, do the quizzes. Thank you and have a nice day.